Okay, so good afternoon. Welcome to another problem that we are going to solve in chapter 8, the confidence interval from the book of Ken Block. Okay, so let's start. So again, if you already watched the video, pause the video and try to solve the video on your own. Okay, so let's start. So suppose, before you read again, you try to draw the framework first, and then every time we read a value, we have to put it in our framework. So suppose the following data are selected randomly from a population of normally distributed values. Construct a 95% confidence interval. So in this particular case here, so the n is 13, 2, 4, 6, 8, 10, 12, 13. And then the alpha here is also given, and then nothing else. So in this particular case, this kind of problem, we have to use the t distribution here. So we have to use we have to get the sample mean, and we have to get the population mean, because we have to get the population mean. So we have to solve the sample mean. How are we going to do that? It's very simple. We have to maximize the use of your calculator now. So how do we input this value here? Okay, and then you go to the mode statistics 3, and then 1 minus var, and then you have to input all the value there: 40, 39, 51, 42, and then 43, and then 48, 45, 44, 39, 57, 43, and why is it that it is still lacking? So you can review if you encoded the right data here. And you have 40, 39, 51, 42, 43, 48, 45, 44, 39, 57, 43, and then 54. There is only 12. 2, 4, 6, 8, 10, 12, 13. Let's review again. 40, 39, 51, 42, 43, 48. Okay, so we have double 48 here. So the lacking is 48, and then simply, after encoding the data, AC, and then you go to shift, stat, and then you go to the var, that's 4, and then this is the sample mean, and then this is the sample standard deviation. We can directly solve the sample mean standard deviation using our calculator. So that's 2, and then press equals, so 45.61. Let's check. 45.62, and then our sample mean is 5.69. So how are we going to get that? So again, shift, stat, because we have to access the stat function here, stat, and then var is 4, and then we get the 4, and then press equals. So that is 5.69. That is our sample standard deviation, as simple as that. Okay, and then we have to use this formula here because the population standard deviation is given. This is the most commonly used in actual research, because the population standard deviation is not normally known. So that is why we have to get the sample standard deviation from our raw data. Okay, and then take note, before we can use the z table, we have to solve for the degrees of freedom. The formulas of the degrees of freedom, that's n minus 1, so that is 13 minus 1, that's 12. Okay, and then we have to solve, this is the result of the distribution plot. We have to get, since this is, what is this, 95%, so that is 0.25, 0.25 here, and then using the t distribution, we have to get this value here. How are we going to get that value? So we have to use the t table. Okay, so we are going to use this one, the 0.025, and then the degrees of freedom 12. And then let's go back here. 0.025. Do not be confused. Please do not be confused with this value here and this value here. So we're going to use this one, 0.25, and then what's the degrees of freedom again? The degrees of freedom is 12, 0.025, and then 12, it's around here, 2.1788. So we're going to look here, 2.1788, or we can negative 2.18. So we simply substitute the value. This is our value here, and then use the calculator to solve, and then this is our the result here. So let me move the result. So that is 42. We are 95% confident that the population mean, the average population, the population mean ranges from 42.18 to 49.06. Okay? So good luck and God bless.